In this video, we shall look at how to solve linear first-order differential equations. A differential equation of this form, as written here, is known as a linear first-order differential equation. Here, P and Q are functions of x only. So you see that this equation is a linear relation between the dependent variable, y, and its differential coefficient. Thus, it's known as the linear differential equation. Such an equation can be solved by expressing it in an exact form. This is the form that we have talked about in our previous video. To get to this exact form, we need a function known as the integrating factor. An integrating factor, let's call it u, is expressed in the following form. It is exponent to the power p dx, where p is this p right there. This is how we use u to turn this equation into an exact form. We multiply this equation by u, and that's going to give you u dy dx plus u py equals uq. From the definition of u, we know natural log of u is just integral of p dx. That means du over u is p dx, which then give us the following important expression. Du dx is just up. Substituting up inside there, we get y du dx. The left-hand side of that equation is just d dx uy, and the right-hand side is u times q. Note that the right-hand side is a function of just x, thus giving us an exact form which is readily integrable. With the following solution, u times y equals an integral of uq dx plus an integration constant, let's call it a, giving us the general solution to this equation. Let's do a few examples. Example 1. We know p in this case is just minus 2. So the integrating factor u is e to the power integral p dx, which is e integral of minus 2 dx, and that's going to give you e to the power minus 2x. Multiplying this differential equation by that integrating factor, you'll get e to the power minus 2x dy dx minus 2 ye minus 2x equals 3. So the left-hand side can be written as an exact form in a following manner. d dx ye to the power minus 2x, and the right-hand side is just 3. Integrating both sides, you get ye to the power minus 2x equals 3x plus an integration constant, let's call it a. We can solve this equation for y to give the general solution, and that's going to be 3x e to the power 2x plus a e to the power 2x, and that's the general solution to this differential equation. Problem 2. In this case, your p is 2. So your integrating factor u is e to the power integral p dx, or 2 dx, which is just e to the power 2x. Multiplying this equation by u, you get e to the power 2x dy dx plus 2 e to the power 2x y equals 8 times e to the power 2x. The left-hand side can be rewritten in an exact form in the following manner. It is just d dx times y e to the power 2x. And the right hand side is 8 times e to the power 2x. Integrating both sides, you get y times e to the power 2x equal 8 integral of e to the power 2x dx, which is just 4 e to the power 2x plus an integration constant b. And we can express y in terms of the rest in a following manner. Y equals 4 plus b times e to the power minus 2x. And that's the general solution to this equation. Example 3. First, we have to reduce the above form into the following form. dy dx plus p y equals q, where p and q are functions of only x. To do that, we have to divide this entire equation by cosine of x. And you get dy dx plus tangent of x times y equals 1 over cosine of x. So this is your q, and that is your p. So since p is tangent x, your integrating factor u is e to the power integral of tangent x dx. And that is just e to the power minus natural log of cosine of x, which is just e to the power natural log of secant of x, which in turn is just secant of x, because e to the power natural log of something is just that something. So there we have it, u, or the integrating factor for this equation, it is just secant of x. Let's multiply this entire equation by that integrating factor, namely secant of x. You get secant of x dy dx plus secant of x times tangent of x y equals secant square x. The left-hand side can be shown to be the same as d dx times y secant of x. Let's see if this is true. Using product rule, dy dx times secant x will give you the first term, plus you differentiate secant x with respect to x times y. So what do you get when you differentiate secant x with respect to x? d dx secant x is 1 over cosine x. Using quotient rule, that's going to give you sine x over cosine square x, which is just secant x tangent x, the term in the bracket. So indeed, the left-hand side of that equation is just that. Equating that to the right-hand side, which is secant squared x, we can readily integrate this equation. Integrating the left-hand side is just y secant x. The right-hand side will become the integral of secant square x dx, and that is just tangent x plus an integration constant, let's call it c. Solving for y, we get y equals cosine x tangent x plus c cosine of x. Note, since sine over cosine is tangent, that cosine will kill this cosine, leaving you with only sine. So your general solution is y equals to sine x plus c cosine of x. And that's the general solution to this equation. Example 4. So in this case, 3 over x is the function p. So the integrating factor is e to the power integral of 3 over x dx. And that is just e to the power 3 natural log of x, which we can write as e to the power natural log of x cubed. Now we know e to the power of natural log of something is just that something, in this case x cubed. That is your integrating factor. Multiplying this differential equation by u, you get x cubed dy dx plus 3x squared y equals 4x cubed. Now the left-hand side can be rewritten in an exact form as d dx x cubed y. The right-hand side is just 4x cubed. Now integrating both sides, you get x cubed y equals x power 4 plus an integration constant a. And now we can express y in terms of x in the following manner. Y is just x plus a over x cubed. And that's the general solution to this differential equation. Example 5. Let's first rewrite the right-hand side in a familiar form. X over 1 minus x squared y plus 2 over 1 minus x squared. Now rearranging, we get dy dx minus x over 1 minus x squared y equals 2 over 1 minus x squared. So you see that is your p and that is your q. Let's work out the integrating factor u. U is e to the power integral of p dx. So p is minus x over 1 minus x squared dx. We can absorb the minus sign inside and write a 2 there and write a half in front. So you see, when you differentiate the denominator, you get the numerator. The result of such an integral is just natural log of the denominator. In this case is 1 minus x squared. Of course, we can bring the half as the power to get that. And this will just reduce into square root of 1 minus x squared. And that's the integrating factor. Now let's multiply this differential equation by that integrating factor. You get square root 1 minus x squared dy dx minus x. 1 minus x squared will simply becomes square root 1 minus x squared after multiplying by u. Don't forget the y. The right hand side is 2 over, again, square root 1 minus x squared. Let's put a bracket there. One can see that the left-hand side can be expressed in an exact form in the following manner. It's just d dx square root 1 minus x squared times y. Because using product rule, d dx of this term in the bracket is just dy dx times that term, which is the first term, plus y times d dx of square root 1 minus x squared. When you take the derivative of square root 1 minus x squared, it is just 1 over 2 square root 1 minus x squared times minus 2x. The 2 cancels and it will give you exactly that term. So you see the left-hand side is indeed the exact form as written here. The right-hand side is 2 over square root 1 minus x squared. Now we can integrate both sides easily. The left-hand side is just square root 1 minus x squared times y. The right-hand side is 2 integral of 1 over square root 1 minus x squared dx. This integral is a standard integral which will give you inverse sine of x. So that means the right hand side can be written 2 times inverse sine of x plus an integration constant b. And general solution is therefore 1 over square root 1 minus x squared times 2 inverse sine of x plus the integration constant b. And this is the general solution to that differential equation. As always, thank you for watching.